Okay, this is a quick tour through the many different types of graphs and charts that we can use in this poster project assignment. There's over a dozen, so I'll go fairly quickly through these. This is also linked to our actual website, so you can go on to the business site that has this. It has links on it, but there's a lot of advertisement and things, so I thought it would make sense to just preserve this and then narrate this as we go through it. Okay, so the first type of chart or graph that they show is a line graph. Line graphs are often used in science or in experimental physics or something where the x-axis is time and something is happening over time, like a chemistry reaction or something. And the implication is that something is more or less continuous, like in a stock market, or in this case, a sales trend. And at one point of measurement, you get a data point. Another time, you get another data point. You can connect the dots if there's a clear understanding that it makes sense to do so, that you can expect that the data would be found in between those measurement times, and it should be continuous. There are times when you don't want to connect the dots, though, because it would be silly to sort of say that between 2 days, there's sort of a half day or something like that that would make sense. So at times you do, and at times you don't connect the dots. Your control variable is on the x-axis, and your dependent variable is on the y-axis. Bar charts are often used to represent categories of things that have a numerical amount. So you could compare sales in particular countries, or in this case, it's just comparing the sales of two products, A and B, and the number of sales is on the y-axis. Now, if these were comparisons of sales in certain countries, you could mix where those bars appear, and you could have, England, France, and Germany, and then have Germany, France, and England, and the order in which you read about those countries would not make a difference. That's a clear indication that this is a bar graph. A histogram looks similar, but histograms you cannot rearrange where the buckets are that hold the data. Pie charts are very common and very useful way of representing data when you have an entire population or you want to show how all of something is divided up. If you survey like all of the students in school and you want to find out their sports interest, you could represent it with a pie chart. Here we've got percentages that can be represented by an angle measure. You just take your percent, 0.4 for 40%, multiplied by 360, and you'll get the degree angle measure of each of your pizza wedges. So again, very visually easy to see how the whole of a population is divided up. Histogram shows how data can be arranged in columns. They're called buckets. You can change the bucket size to suit your data. Here we have per capita income for different age groups. You would not want to rearrange the orders of your age group because it wouldn't make sense that way. Here the buckets are 10-year groups. You could change that to get finer gradation. So your calculator can do this. You can also do these quite easily by hand. Computers also do those types of graphs very easily. A scatter plot is when you're comparing X and Y data, so two lists, two sets of data, and you want to see how if one thing increases, does the other quantity increase or decrease? There can be all sorts of relationships. In this case, they're showing a linear relationship between, I think it's advertising dollars spent and then the increase in sales. Makes sense. The more you spend in advertising, the more the sales might go up. Here's a line that fits that, and it's called a regression line. The better the data fits the line, the higher the correlation. If it goes up as you read to the right, it's a positive correlation. If it goes down, it's negative correlation. A Venn chart is using circles to represent sets of things where they intersect. That is a commonalities to both of the sets. So here we're comparing bats and birds. Both have two legs, both fly, etc., etc. But then there's differences between bats and birds, and so you can put those outside of their respective circles. Area charts are a way of showing accumulated amounts, trends. It's an easy visual way of getting a sense if the quantities are displayed below the lines. So it's a little bit like a continuous sort of a bar chart or a histogram. Histogram is a better way of representing that. A spline chart is where you have spokes on a wheel and you can give different quantities as you go out. Oops, nope, I narrated that wrong. This is a curved broken line that smooths out and shows the continuity of a graphing data, so it's a little bit less pointed, a little bit emphasizes the continuity of a graph. Box and whisker chart we're well experienced with in class. You can do this on your calculator as well. You can do it by hand. It's based on dividing your data into quartiles. You have a minimum value, a maximum value, a middle, median value, and then the middles of each half, upper half and lower half, will be your first quartile and third quartile. Typically we do them horizontally, so there's an example here that shows two data sets that will be represented with horizontal ones. Notice if you glance at the numbers, it's difficult to get a sense of what's going on, but with two box plots, you can quickly see that even though they have the same range, the bulk of the math data represents higher scores, and the bulk of the literature data is lower by comparing their medians. A bubble chart is a way of comparing multiple qualities in one simple XY plot. You can see that you've got an X and a Y axis, but where you plot those bubbles by their size and by their color can tell you two more important pieces of information. This is the concept behind that Hans Rosling video about world health. It can be a very effective way of conveying a lot of information at a glance because you get those four factors involved. Pictographs are similar in that we're using small icons to represent certain things. So in a glance, you can see there's more computer sales in February than January. You know what it is and you know how many, so it's a very effective way of doing that. Dot plots represent each data point. It's an easy way to get a sense as to the distribution, the shape of the data distribution. Is it normally distributed? Is it bimodal? Is it uniform, etc.? The radar chart is the one that is like spokes in a wheel that go out, and you can compare the quantities. You have here 5 things, like 5 spokes. The degree to which that quantity, that attribute is happening is the distance away from the origin, so you can kind of get a glance and make sort of a two-dimensional picture that's easy to get a sense as to where quantities are strong or weak. It's quite unusual, and we do not have a computer program that does that. Pyramid graph, very simple like the name implies. It's a lot like, in this case, they're using the food pyramid. It's where you have a hierarchy. Things are sort of placed in order, like in biology, and you have a lot of things at the base and 1 or 2 things at the top. So hopefully this has been helpful. It was a quick mad dash through types of graphing, and hopefully will be useful to you.